Characteristics of transformed function. So with the help of this test problem, we'll try to understand exponential function. So the question here is, consider the function y equals to minus 3 to the power of x plus 1. Describe characteristics of the function, which means domain, range, asymptotes, increasing and decreasing intervals, x and y intercepts. This is what you need to do for this exponential function, the transformed exponential function, right? Let's first look into the original function, which is 3 to the power of x in this particular case, right? So let me sketch the function 3 to the power of x for you. So 3 to the power of x will be a function kind of like this. Do you see that? So this is what I've drawn as 3 to the power of x. The important points here are, when x is 0, then anything to the power of 0 is 1. So this is a very critical point. And the second is, if x is 1, so let me say x is 1, let's say this point is when x is 1, this point is, let us say 3. So anything to the power of 1 will be the base itself, if the exponent is 1. So, right, these two are critical points. And third is this. So what is that? It is a horizontal asymptote, right? So here we notice that we have a horizontal asymptote, and let me write horizontal asymptote as the function as x approaches minus infinity, a negative large value, you will find that value of the function approaches 0, right? So it is approaching a value, but it is not right there. And therefore we say horizontal asymptote is, so the equation of horizontal asymptote is y equals to 0, the value which you are approaching but you're never there. So these are the characteristics of our function 3 to the power of x, the parent function for the given transformed function. Now let's look into how will this function get transformed. So let's write down the transformations for the given function. For y equals to minus 3 to the power of x plus 1. So as you see, number one transformation you should see from left to right. So if you move from left to right, left is this, minus, that means reflection on x-axis. Now if I reflect it on x-axis, what really happens is range changes. Earlier the range was greater than 0, but now it becomes less than 0. So that is the major effect. Direction changes of increasing. Earlier the function was increasing all throughout, now it becomes decreasing all throughout. The y-intercept changes. Instead of 1, we have it at minus 1. You see? So many parameters change for the transferred function just by doing this minus. Okay? Second, what we see is plus 1 here. Now this plus 1 is vertical movement by 1 unit, right? So we say translate 1 unit upright. Now with that translation, its domain and range will change, right? Now domain of this function is actually all real numbers, so that is not going to change. Since it is all real numbers, there is no restriction, so the transformations will not change the domain. So domain will remain all real numbers, correct? But as far as range, asymptotes, increasing and decreasing intervals, x and y intercepts are concerned, all of them will change. Now you have to look into it, analyze it, and then answer the question. So minus will actually move it downwards. So I'll just reflect it on the x-axis, and then I say, well, this is the function minus 3 to the power of x, right? And this point still being at minus 1, right? This is plus 1 reflected to minus 1. And finally, when we have to move it 1 unit up, so this point will actually come here, right? And everything will move by 1 unit. 1 unit it will move, right? So what really happens is the horizontal asymptote, which was at x equals to 0, now all of a sudden comes at 1. Do you see? That becomes your horizontal asymptote. And your graph will now be approaching this, going through origin and kind of like this. Do you understand? And approaching this, please. So that becomes your function y equals to minus 3 to the power of x plus 1. Do you understand? So that is how your function is going to be. Now from this function you can write all the characteristics.